All right, welcome to the Mole Vodcast number 2. This is Miss Carr again. Today we're going to get a little deeper into the mole and how it can be used to do things and calculate things in a chemical laboratory. So first we need to discuss how you would calculate the molar mass of something. Now the first thing you might be saying is, what's a molar mass, right? So a molar mass is simply the mass in grams of 1 mole of a substance. So if we say, what is the mass of 1 mole of carbon, for example? Well, that's how much does 6.02 times 10 to the 23rd molecules of carbon weigh. So it is molar mass. It is expressed in units of grams per mole. So how many grams are in a mole of any substance, okay? And so how do we know or calculate the molar mass of those elements or compounds? So how do we know how much carbon weighs? Well, as you recall, the information that we get given from the periodic table is that we know the mass of an atom of carbon. So we just have to keep in mind that the way that they calculated the Avogadro's number, right, a mole, is the cool thing. We don't want to have to do the math, and so atomic mass units are the same as grams of molar mass. So if you have the atomic mass of carbon is 12.011 AMU, the molar mass of carbon is 12.011 grams. So that at least is a very simple way of thinking about molar mass. That is if you're dealing with a single element. Now, things can get a little more complicated when you start talking about molecules, because there we're looking at just carbon. So you look at the periodic table, it tells you the mass. And that is the mass in grams of 1 mole of carbon. Okay? So there are a few technicalities here and vocabulary words that you do need to be made aware of. These are different vocabulary words that you may see on different tests that would lead you to perhaps misunderstand some of the mole concepts that we've discussed. Now, the molar mass is the mass of 1 mole of any substance, right? So the name of the particle of an element is an atom. So if we say, what is the molar mass of carbon atoms, then we're looking at a mole of carbon atoms, versus the name of a particle of a covalent compound, which would be something like water, like an H2O molecule. So the molar mass of a water molecule would be different from the molar mass of a hydrogen atom, because you're dealing with a compound versus an element. Now, the name for a particle of an ionic compound is called a formula unit. We don't actually call those molecules because they are bound in a different way. So those are formula units. So if you see any of those terms, I want to make sure that you're not confused by them. Please take a moment to pause the video and write down these terms so that they don't confuse you later. Remember, an element, okay, the name of the particle is an atom. For covalent compounds, the name of the particle is a molecule. For ionic compounds, the name of the molecule is a formula unit. Okay? So technically, the molar mass of an element is called the gram atomic mass. And technically, the molar mass of a covalent compound is called the gram molecular mass. And the molar mass of an ionic compound would be called the gram formula mass. But we use the term molar mass to describe all of these things. So if we ask for the molar mass of water, you know that water is a covalent compound and therefore would be the gram molecular mass. But it's all molar mass. So you will often hear me refer to these as simply the molar mass of these different particles. So how do you find the molar mass if you're dealing with something that you can't find on the periodic table? For example, water. You're not going to find H2O on the periodic table. But what you can find is H and O. So we're going to calculate the molar mass of CO2, carbon dioxide, which has 1 carbon atom and 2 oxygen atoms. The first thing you need to do is find the molar mass of your individual atoms. You have 1 carbon atom. We know that its molar mass is 12.011 grams for every mole. Then we have 2 oxygen atoms. We know that their molar mass is 15.999. Of course, that again from the periodic table. We have 2 of them, so we multiply this 15.99 times 2. Remember, you're getting this information from the original formula of your molecule. So you have 2 times 15.999, and that will give you your total molar mass of your oxygens. Then to find the total molar mass of CO2, as you may have figured out by now, what do you want to do with those masses? Well, we simply add them together. This will give us the molar mass. That's the mass in grams of 1 mole of carbon dioxide molecules. So if you had 6.02 times 10 to the 23rd molecules of CO2, you would have 1 carbon and 2 oxygens for every one of those molecules, and it would weigh a total of 44.009 grams per mole. Okay. To give you another example, we have what is the molar mass of aluminum chloride. This is an alternative way that you will see these kind of problems given, primarily because we want to make sure that you can go back to your first semester of chemistry and convert that nomenclature into an actual formula. So can you remember how many aluminums would bond with how many chlorines to produce an aluminum chloride molecule? So I'm going to give you a second, and I want you to think about that and write your answer on your own paper, and then unpause the video and see if you got it right. If you didn't, you may want to review some of our nomenclature stuff from the first semester. Okay. First, we know that aluminum chloride contains aluminum, okay, and it contains chlorine. Okay. The question is, how many of each? Remember that your aluminum has a charge of +3, where your chlorine has a charge of -1. If you need to review how we know this, again, pay attention to your periodic table. Okay. Now, this leads to an aluminum chloride molecule, which has 1 aluminum for every 3 chlorines. So if we had a mole of aluminum chloride molecules, then we would be able to correctly predict that 1 aluminum, based on what we know from the periodic table, is 26.982 grams. And then our 3 chlorines would be 3 times the weight or mass of a chlorine mole, which would be 35.453. So you multiply those together, okay, and we get 106.359. You add those two to get the total mass of 1 mole of your aluminum chlorine or your aluminum chloride molecules. Okay, and of course that is in the units of grams per mole. Please do not forget your units on these problems. If you have simply a number, it means nothing. A number with a unit suddenly has meaning and is therefore worth points on your exam. Okay. All right, I'm going to give you another example. For this one, we're going to use a transition metal. I do want you to remember your nomenclature for your transition metals. For iron 3 sulfate, please try to pause the video and go ahead and write the formula for iron 3 sulfate and check to see if you got it right. Okay. Well, of course, we know iron, it's Fe. Okay. And we have SO4, which is our sulfate polyatomic ion. So in this, we have 4 oxygens, 1 sulfur, and 1 iron. The only problem is, what does that 3 in the Roman numerals mean? Again, if you go back to your nomenclature, you'll remember that that 3 indicates the charge of that iron. So we're going to put that +3 charge up there. So we're directly translating this 3 into the charge of +3. Then if you look on your polyatomic ions chart, or if you're really good, you memorized this at the beginning of the year, your sulfate ion has a charge of -2. Now, again, if you use your bow tie cross method of calculating your formula, you will see that you have 2 irons, and then you have 3 sulfate ions. This is where some people get a little messed up because they don't know how to use that 3 to calculate how many of each of the atoms you have. So the first step you really need to do here is to count how many of each of these atoms you have. So we know we have 2 irons, okay? You have 2 times the molar mass of iron, which is 55.845. Again, we find that number from the periodic table, okay? That gives us a molar mass for our 2 iron atoms of 111.69. Then we have 3 sulfurs, and the way that we got this number is the 3 on the outside of this parentheses, remember, applies to everything inside of the parentheses, just like in math. So this 3 applies to the sulfur and the oxygen. So we have 3 times sulfur. So you have 3 times the mass of the sulfur from the periodic table again, and that will give us our total sulfur mass of 96.18 grams. Then this last one is the one that confuses most people, in that, do you add these numbers, do you subtract them, or do you multiply them? And the answer is yes, you multiply them, because it's 0.4 times 3. So you're having 3 of these oxygen 4s, so you have 12 total oxygens. Now that means that you have 12 multiplied by the molar mass of oxygen at 15.99, and your total there would be 191.988. And of course, just like with all of our other molecules, you add these total masses together, and it gives you the final mass of an iron 3 sulfate mole is 399.858 grams in 1 mole of iron 3 sulfate. Okay? All right, and that is